right, so we talked about solids, we talked about liquids, now we're going to talk about gases. So our chemistry definition of a gas, these are particles that are not packed, and they have complete freedom from each other. All right, so they're not packed and they have complete freedom from each other. So this is my solid, vibrating. This is my liquid, kind of moves around a little bit. This is my gas. They're really far apart. If you can look here, there's a lot of empty space. They're far apart and they're constantly moving, okay? So they're not packed. There's complete freedom from each other, okay? These particles, like I just said, these particles are constantly moving, okay? So they're constantly moving, and there's a lot of empty space between the particles. Okay, so the particles are constantly moving, and there's a lot of empty space between the particles. All right, so let's talk about a few things. Shape. So just like we talked about a liquid, if I put a gas into a container, because it's constantly moving and it can be spread out like this, it's going to take the shape of whatever. Okay? So if I put it in a room, if I open a gas in this room, it's going to spread out to the room. If I put it in a balloon, it spreads out into a balloon. So the shape is whatever the container is. So it has an indefinite shape. Volume. Now, the difference here with the volume is that they're not packed together. They're spread out. So because they're spread out, that means the atoms are spread out, which means the gas itself can spread out, so the amount of space it takes up can change. Okay? So because they're not packed together, they can take up a different amount of volume. So the volume is going to be indefinite. All right, compress. Can I compress a gas? So like I said, they're not close together. They're spread out. So because they're spread out, that means I can compress them. There's all this empty room here, so that means I can smush them together and compress the gas. Whoops. And the last one is flow. Can a gas flow? So since it's constantly moving, then it's able to flow. It can move around in the room. So yes, it can flow. All right, so we said, just to kind of refresh with our gases, that they are compressible because they're moving freely and they can expand to fill and take up the shape of the container, and they will flow. So we actually use this idea of them being compressible in our engines. So in our engines, we have gas here. So think about with our fuel, it's a liquid, but when we heat it up, it becomes a gas. And so we have a gas, we could compress this gas, and then it's going to kind of fight the compression, and then we get energy out of this. So we're compressing the gas, and then this is how we create some energy. And we'll talk about that a little bit more in later chapters. All right, so now we talked about one way to classify matter. We can classify matter based on if it's a solid, if it's a liquid, or a gas. Another way that we can classify matter is based on its composition. So that was based on its state. Now we're going to classify matter based on its composition, and we're going to kind of make a little diagram, a little table. Okay? So here we are going to use, these are two examples, tap water and distilled, and we're going to talk about what type of matter is it. Talk about is it a pure substance or a mixture. And then on the next two slides, we'll say if it's a pure substance, it has two different subcategories. And if it's a mixture, there's two separate subcategories. So we're kind of making a little flow chart. Okay, so let's talk about this one first. Let's talk about the difference between a pure substance substance and a mixture. All right, so if I'm a pure substance, I have some qualities. So first, if I'm a pure substance, I'm going to be made of one atom or molecule. So think about, I'm only made up of one thing. I'm going to be made of one atom or molecule, and all my samples show the same characteristics. Okay? So all samples show the same characteristics, and I'm made of one atom or molecule. All right, let's talk about a mixture. It's going to be similar. Instead of it being made of one atom or molecule, these guys are going to be made of multiple types of atoms or molecules. Yep, I hit the side here. And I'm going to talk about the difference between an atom and a molecule later. Okay? So these are going to be made up of multiple types of atoms and molecules. Second characteristic is that all samples have different characteristics. Okay? So pure substance is made out of one atom or molecule, mixture is made out of multiple. The pure substance has all the same characteristics. This is different. So let's talk about our two examples. I have tap water and distilled. So based on this, I have to look and see, is there one thing or two? So in my distilled, I have nothing but blue little dots, blue little circles or atoms here. And then in my tap water, I've got blue and red and yellow and green and orange. So I have a bunch of different things. So just based on our first little definition, this is made of one thing, this is made of multiple. So this is my pure, this would be my mixture. Now let's talk about the second part. So this would be my pure, this would be my mixture. Now let's talk about the second, the same characteristics. If I were to take a sample from here, this is my distilled container, and I took it from the very top, I only have water. Okay, I only have my distilled water. If I took it from the very bottom, it'll only be the little blue atoms, molecules. If I took it in the middle, only blue. So it'd all be the same. For the mixture here, if I took it from the top, I'd have mostly blue, but I'd get some green and some orange, some yellow, but I probably wouldn't get a red. If I took it from the bottom, I might get a red, but I've got a lot more, green and orange down here. If I took it in the middle, I've got mostly colored. It's more like a 50-50 split. So depending on where I take my sample, I'm going to have different things in it. Different colored atoms, molecules. So my characteristics are going to be different for each sample. Okay? So that's a mixture. This is a pure substance. So now what we want to do is we want to talk about the pure substance. Okay? So in the next video, we're going to break down what are the two different components of a pure substance.